My console?
Console.
Yeah.
Okay, perfect.
That's
So
the
we're live
console.
now. So I'm going to create an EC2 instance here. Okay. And then in the EC2 instance, we're going to create 1 and 3 availability zones. Okay. 1 in each availability zone. So we follow here the steps. We select the free tier instance type. Right now, we're going to say, okay, I want to use the default VPC. I want to put this in the 1A availability zone. And here, I want to say enable, right? And in the user data, I want to say, well, this bin bash, right? And I want to say yum -y update, and then yum -y install HTTPD, which is Apache. Okay. Now we'll say systemctl. We're going to say start HTTPD. And we're going to say systemctl enable HTTPD. Okay. So that's going to be our code so far. Right now, we're going to echo something. I'm going to echo HTML. So I open HTML H1, I close H1, and I close HTML. Okay. I close the quotation marks. And whatever I put there, I want to redirect it and create a file inside var, inside www, inside HTML, and then inside I want to say index.html. Okay. So this instance is instance deployed or launched in US East 1A AC. Okay. Perfect. I'm going to copy this so I can use it in my next instances. Okay, make sure that everything is correct here. Okay.
You put it in Slack?
Yes. Okay, so we're gonna be careful with the quotations. You have to change the quotations. If it has a simple error, it won't work. Okay. So now that we have this, we're going to add storage. Nothing to do there. The tags, I'm gonna say name, and then Apache web server US East 1A. Okay, perfect. So security group, let me see. I have one here called Apache Web Server Security Group. I already have it here, right? I'm gonna use it, one that I created before. You should have it there too, guys. Now I'm gonna review. Everything is fine. And then I'm gonna use this key, just in case I need to SSH into my instance. So my first instance has been created. Okay, I'm gonna go ahead and do the second one. You can do the same, guys. Create another one. Just hit next. 1B, enable, come on down here, copy this and say 1B, right? Perfect. Storage, tags, name, Apache web server, US East 1B. Security group, I'm going to select the one that I selected before. Review and launch. Use the key and launch. Right? Now I'm going to go ahead and create the other one. Okay. I'm going to go ahead and skip this. And then use C. Enable. Scroll down to the user data section. You see here. And tag name. Apache, and then Apache 1C. Perfect. Security group, I select one that I already created. Review, launch. Select the key, and perfect. I have 3 instances now in my account. I guess I can test this too. Okay, I can test this one. Come here, hit this, and it says instance launch in US East 1 AZ. I can test the second one. US East B, and I can test the third one. This one will take a while. Just wait for it. Okay. It has the same security group. It has a copy of the user data. So there shouldn't be any reason why it doesn't connect. That's right. So it's right there. So we have A, B, and C. Okay. So perfect. Now we have 3 availability zones with 1 server each, right? Now, right now, I can access my instances directly. So which is somehow not good, right? So why not put an elastic load balancer in front of them? And what I have to do is just use the DNS name of the elastic load balancer and just refresh the page, and you will see how it changes from 1B, 1A, 1C, 1E, 1 like that, right? So let me go ahead and create an elastic load balancer. I'm going to go ahead and right-click here.
Professor, I have a question real quick. How come like the website doesn't say, or how come it says not secure if you installed like a security group?
No, it has nothing to do with that. What guarantees that this is secure is a certificate. I don't have a certificate. Okay. So this one has a certificate. This lock here.
Yeah. Yeah.
So for that, I will have to purchase a certificate.
Got you.
So okay. AWS has something called Amazon Certificate Manager.
Right.
I can purchase that from there. Right.
Okay.
So I'm going to go ahead and right-click here and open a new tab with the load balancer. Okay. So I'm going to go ahead and create a load balancer. So in this case, we're going to create a classic load balancer. Okay. So we're going to say create, and I'm going to say my classic load balancer. Okay. It's not going to be an internal load balancer because this one's going to be facing the internet. Okay, so it's not.
Wait, sorry.
Internal.
Did you select the network one?
Huh? No, I selected the classic one.
Oh, classic. Okay.
Classic. So classic load balancer. Okay. So now that I have this, I'm going to use the default VPC. I'm not going to check this. I'm going to check this, right? What I'm going to do is hit continue, right? We're going to add a security group. So I'm going to create a security group just especially for the Elastic Load Balancer. So I'm going to call this ELB security group. Okay, I'm going to create one especially for the load balancer. So the description is going to be the same thing, but I'm going to separate this into 3 words. Remember, the name has to be only 1 word. Okay, so the traffic is going to be on port 80, and it's going to be the entire internet. So this is my security group. Okay, perfect. So next, configure security settings. Okay, now this says improve your load balancer security. Your load balancer is not using any secure listener because it has port 80. Okay, port 80 it's just the entire world. That's okay. If I use port 443, which is secure, it wouldn't say this, but I chose HTTP, not HTTPS. Okay. So I think it was, who was that? Priyanka? I think it was you who asked me about the time. The time to declare something unhealthy?
No,
Okay.
I just asked like why was CloudWatch needed?
Yeah, but someone asked me the time. I think it was Utah probably. I don't remember. Well, this is the
time. I was just wondering what happens if the
okay.
I think I asked that question.
Who are you?
Namrata.
No. I have so many people with the similar voices that sometimes I get confused. Response timeout. This is the time to wait while receiving a response from the health check. Right? 5 seconds. The interval is the amount of time between health checks. 30 seconds. So every 30 seconds, it's going to send the health check. The unhealthy threshold. This is the number of consecutive health checks failures before declaring an Ec2 instance unhealthy. So it's going to send 2 checks. After that, no response, it's considered unhealthy. And for healthy, it doesn't have to be that few. It can be more, right? Because it's always healthy, right? But I can reduce this if I want to. But this is fine. The default settings are fine, right? So the pin path is going to look for that particular file. That's going to be the health check. Looking for that particular file on port 80, and the protocol is HTTP. Okay, so your load balancer will automatically perform health checks on your Ec2 instances and only route traffic to instances that pass the health check. If an instance fails the health check, it is automatically removed from the load balancer. Customize the health check to meet your specific needs. Okay. Now I'm going to add the Ec2 instances. So see here, I have these 3 heights here. Cross load zone load balancing is already selected, and this is the one that distributes the traffic evenly across all targets in the availability zones enabled for the load balancer. Okay, so this guy is going to be working with the 3 availability zones here. Right. So right now I'm going to check all of them. Perfect. And the enable connection training is the number of seconds to allow existing traffic to continue flowing. 5 minutes, right? Tags. Well, I don't want to add any tag here. I can say name my classic load balancer, but that's fine. Why not?
Wait, can I ask a question really quick? That 5 minutes, it's saying that the traffic will continue coming to something even if it's unhealthy for 5 minutes?
No.
No.
Yeah.
Could you explain that?
Okay, let me check. Let us check the documentation. Connection training. So you guys can have a better explanation from AWS. Okay, so here. So you can use Elastic Load Balancer on its own, or you could judge with schedule, combine data. Okay, connection training. Today's new feature sits squarely at the intersection of activity. Okay, No, that's not what I'm looking for. Okay. When
Yeah, that right
connection
there.
training is enabled and configured, the process of deregistering an instance from Elastic Load Balancing gains an additional step. For the duration of the configured timeout, the load balancer will allow existing in-flight requests made to an instance to complete, but it will not send any requests to the instance. During this time, the API will report the status of the instance as in service, along with the message stating that the instance registration currently in process. So once the timeout is reached, any remaining connection will be forcibly closed. So 5 minutes to keep the connection open. That's what it means.
Okay.
So it will let existing in-flight requests get to an instance to complete, but it will not send any more traffic to the instance.
So basically, is this the way how it balances the load, that for only 5 minutes it will allow traffic to one instance and then it will switch over to the another instance?
Yeah, that's what the instance is being deregistered.
Okay.
In the process of being deregistered, it would allow that, right? When the registration is happening. So let me see here for the class load balancer. To ensure that a class load balancer stops sending requests to instances that are deregistering or unhealthy while keeping the existing connections open, use connection training. This enables the load balancer to complete in-flight requests. Remember, your instance may be deregistered, but there were requests that were already sent. So they are in flight. They're not on the client side or on the server side. So they are in flight, right? Something has to be done with those requests, right? So it allows the load balancer to complete those requests made to the instances that are deregistering or unhealthy. You will see that when an instance is stopped, it is deregistering from the instance when it's declared unhealthy. Okay.
So, Professor, what happens like this request is in midway, and by the time it reaches the instance is already like stopped. So how will it?
Okay, if the instance is not deregistering, this doesn't take effect. It's when it is in the deregistering state. Instances are now when I add them here, they're going to register to the last load balancer, and it would take some time because it's a process. It has to register, and we'll see here.
I got your point. My question was,
yeah,
if some instance is getting stopped, so the load balancer can see that it is in the process of deregistering itself. So it is that time that it doesn't allow fresh requests to flow through it, but
correct.
the request which is midway, which has already passed the load balancer,
Correct.
it has not yet reached the instance. But by
Correct.
the time request reaches the instance is stopped. So now
Correct.
means that request will be lost. Nothing will be done with that request.
Which way, with the one in flight, it will be completed. So it allows the load balancer to complete it. It says this enables the load balancer to complete the in-flight request made to the instances. It will complete it.
Load balancer will do its job, but
Yeah.
my question is not pertaining to load balancer. I'm asking that in-flight request that load balancer allowed to pass through it because this instance was in the process of deregistering or getting unhealthy. By the time that instance that request reaches the instance, it has already stopped now. It was midway earlier. Now it has already stopped. So what will happen to that request now?
Okay, let us continue reading here. Okay, so this is when it's deregistering or unhealthy, right? So it doesn't have to be unhealthy. It can be deregistering, right? One or the other. Okay, when you enable connection training, you can specify a maximum time for the load balancer to keep connections alive before reporting the instance as deregistered. The maximum timeout can be set between 1 and 3600 seconds. The default is 3 seconds. That's the one that he has now. When the maximum time limit is reached, the load balancer forcibly closes the connections to the deregistering instance, right? So the in-flight request will be completed, and then once they're completed, the guy is deregistered, right? Or
Yes.
if there are a lot of requests and it gets to the 5 minutes, those requests that were never completed, then just in case there are many requests, after 5 minutes, the instance is simply dead and the connection is closed, right? So you have like 5 minutes to process in-flight requests, right?
So that
Until the instance becomes deregistered, it's completely gone. It's not connected to the load balancer anymore. So it will keep the connection alive because there are requests in flight that were not processed. They are in the process of being processed. You know what I mean?
so that means that if the connection training timeout is this 300 seconds is reaches, so if
Yeah.
at that moment also if there is some in-flight request that will be
Will
dead.
not be processed because the connection training time is exceeded. It's just maxed.
Okay.
That's it. It's 5 minutes. So the 5 minutes will be for all the requests that can be processed in that time. After that, the connection is closed. But you have 5 minutes. You know how many requests you can process in 5 minutes? It's a lot, right? In the case in our instances will be deregistered as soon as the process is complete because we won't have any in-flight requests, right? Because our instances is just testing. We're just testing. We don't have a live website or anything or application. But there might be some requests that were made after the instance or before the instance became more healthy. But those requests are there, they're hanging there, they need to be completed. So those 5 minutes would allow the balancer to complete those requests. So it will keep the instance as in service, right? As in service instance registration currently in process. So the instance is not out of service, it's in service still, right? So once the 5 minutes have, finished, it's going to say out of service. Instance is not currently registered to the load balancer. Do you guys understand? So if an instance becomes healthy, the load balancer reports the instance state out of service. But if there are, and this is what it's going to happen to us, because we're not going to have any in-flight requests, right? Now, if there are in-flight requests made to the unhealthy instance, they are completed. The maximum timeout limit does not apply to connections to unhealthy instances, right? So if your instances are part of an auto-scaling group and connections draining is enabled for your load balancer, auto-scaling waits for the in-flight request to complete and for the maximum timeout to expire, or for the maximum timeout to expire before terminating instances due to a scaling event or health check replacement. Right. So basically, guys, that time, connection training, is the time that the load balancer has to complete the requests that are pending, right? Once the time has passed, right, the connection is closed. So that's the time that we are setting here, the 5 minutes. Where is it? Here. Okay, so these are the instances that are registered with this. You see now that when I create the load balancer, if I click on my Elastic Load Balancer and I take a look at the instances, you see that right now they are out of service because the instance registration is still in process. You see? So the instance is not registered right away. It's a process that would take time, right? Approximately 2 or 3 minutes, most likely, maybe less. You see, you have to wait, right? Okay. So that connection draining timeout time, it's going to be here. It's going to say in service, and then this registration process currently, according to the documentation, is currently in progress. Instance registration currently in progress. Okay. So let us do this. This one is in service already, right? And the three of them are in service. Now, see how cool now this is, right? Now they are in service. So all the instances are in front of or behind the last load balancer. So now in the description, I have this DNS name, right? So I can go ahead here and copy this in the browser. And now we're able to see the instances, but now we don't see an IP address, we see the DNS. Look at this. You see how it's sending the traffic to the three instances? So that's what the last load balancer does. Okay. But we still have a problem. People can still access our instances through the IP address. You see? You see? We don't want that. We don't want that. We want people to access our instances only through the last load balancer, only through this guy. Right? So this is just a security group matter. So we have to fix the security group. So what we have to do is come to the Ec2 instances, right? And check the security group, right? Come here to the security group, in the security tab here, move there, right? And here, what we can do is edit the inbound rules. And I'm going to remove this guy, right? And I'm going to check. I'm going to say here that I want my this guy to be custom traffic, custom TCP. And here I'm going to say SG, security group, and I will select the security group from the last load balancer right here. So it means that only the source to come to these instances is through the security group of the last load balancer. It means that no one would be able to connect to my instances using either the IP address or the DNS, because an Ec2 instance also has a DNS. Okay, you take here, we have a DNS here. So this is basically the URL of the instance. If I type this here, I still get the value of the print. So I can use either an IP address, which is this one, you see, 64.236, or the DNS, and I will be able to connect. But I don't want that. I want only people to move or enter or access my Ec2 instances through the Elastic Load Balancer. So I can go ahead now, I save this rule. And now if I do this, I get a timeout. Look at this. I get a timeout. Look at this. Timeout. 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 So the four of them will time out after some time because the security group is not allowing any traffic from the internet. And the only source is the Elastic Load Balancer. And now this guy is the king. You see? This is the only point of entry. I just decouple my application. So right now, I can see my guy is just moving from one to the other one, right? Right? And this one just timed out, as you can see. This one timed out. as you can see. This one timed out, and this one will time out. Okay, but the last load balancer still showing. Right? Weird that it's not showing C. So C is here, right? C. So instances. Okay, all of them have the same security group. Let me see C here. Security group. Okay, Apache has the security group here. Perfect. Let me take a look at the last load balancer. CCE. You see it's healthy. Okay. Load balancer. Okay, load balancer. Let me take a look at the instances. Fee is healthy. Okay, and fee is registered. So it's not showing C here. Okay, let me close this and get the DNS again. Okay. And now I'm able to see it's getting A and B only. That's weird. That's weird. It's supposed to get C as well. Okay. But the point is,
mine's getting C.
okay, yeah, it should get C. I don't know what's not showing C here.
I changed my rules too to the ELBC security group.
Yeah, when you change the security group 1, it will change the security group all of that, all of them because
Copying the user data, you have not changed it here because it changed in the user data. So it is changing, but it is only showing as B.
yeah, it's supposed to show, but it's supposed to show C here anyways.
No, like this thing is hard coded, right? So it might be possible while creating the instance, you just copied the user data and you have not made the change there.
Did I? Did I not? I think
I'm
I
not
did.
sure. I'm just.
You did.
Let me. I think I did. Let
It
me
showed
show.
C before.
Yeah. It's right here. This one here. So I'm gonna see. Is the settings user data? It's right here. So yeah, that's okay. That's okay. It's supposed to, but it's not. So that's fine. Okay. If it's showing up for you guys, that's perfect. So, well, what we just did, we added our instances, one in each availability zone, right? We created a class load balancer. We put the last load balancer in front of the instances. We register the instances with the last load balancer. And we changed the security group to allow traffic only and only through the last load balancer to my instances. You can use the IP address of the instance as many times as you want. You can even get tired, get delighted, enjoy it. You know, yeah, I don't know, whatever. You would never get anything, no matter what you do, because the security group is simply not allowing you to. Right? So the only source is the elastic load balancer. Right? That's what we're doing here. You see here, now showing C. You see? Perfect. That's what it's supposed to do. Sometimes it adds up a little bit, right? But that's what's supposed to do. Okay? Good. So it's working.
Oh, wait, can I ask you a question? Did it have anything?
And I can give you an answer.
Did it have anything to do with now that oh Lord, let me see, the tab you have, the 1, 2, 3, fourth one over, right here with your IP address? Over, keep going, one over, fourth one over from the left.
This one?
Your fourth tab.
Your fourth
top.
tab. That one stopped spinning
No,
around.
your fourth tab, not your sixth one. That one.
Did
it times out.
Did it have anything to do with the fact that that timed out? Because it wasn't timed out, and then it timed out, and then you could see one.
Because I changed the security group, remember? When you change the security group,
right?
Because before the security group source was the internet. So before, here, instead of being the security group of the elastic load balancer, it was 0.0.0.0/0. Remember? And that's the entire internet. That's why people could access my instances one by one with IP address. But now I changed that. I'm using the best practice here. I'm using my elastic load balancer security group as the only and single point of contact. So now the source is only the security group of the elastic load balancer. That's why I'm able to see this, because this is my elastic load balancer, right? If you try to access my instance, the web browser, with the IP address, you see it's spinning. It's gonna get tired of spinning and it's gonna time out. As you can see, it's just timed out. It's just timed out. Okay. You need to open port 80, and I will do it again, guys, for you to understand. I'm gonna open port 80 again. So I'm gonna remove this guy, and I'm gonna say 0 and 0 and 0. Okay. Now the elastic load balancer will continue to show. This will continue to work. Okay, it doesn't matter, right? But now I could go ahead and refresh here. You see, it shows me this, right? So this is 1A. I can still see 1B if I just get the IP address of 1B. And 1B is right here, right? I get the IP address, and this is 1B, right? Because the security group is allowing all this. Look at this. Security group is the internet, right? Now, if I change it back to the security group of the elastic load balancer, right here, this is the only source, nothing else. So now if I refresh, it will time out. You see how it start spinning? It will time out. So the only source is the elastic load balancer. You see? So now what you have to do, guys, is give this to someone, and you can go ahead and take a look at my elastic load balancer, right? Give it to someone, and now you can, people, can you click on the link that I just posted on Slack, and you will be able to see what I see here, right? And start refreshing the page, and you will see. Can someone share the screen to see what you see? Anyone? By clicking on the link that I left there.
US is one.
Can you share the screen, please, Kenneth?
I use my phone.
Okay, someone else, please. Okay, Shita, can you refresh the page? There you go. Refresh, continue refreshing, please. You see? And that's my elastic load balancer, right? So it's live, right? Now I can go ahead and in Route 53, connect my domain to this website, and it's gonna look like a normal website. And behind it, there's a load balancer. Would you be able to realize there's a load balancer when you see, for example, www.classroom.site? How can you know there's a load balancer behind? There's no way to know it unless you're the one that configured this. So load balancers will stay there, you know, with a low profile, behind the scenes, just distributing the traffic, right? Distributing the traffic in silence, but doing a great job here. You see? Perfect, guys. Perfect.